This video will define the optical axis for thin lenses and also define the principal rays for a convex lens, which we will use to draw ray diagrams that allow us to locate the image in a diagram. So we start out with an object and a convex lens. The first thing we need for our ray diagrams is to draw in the optical axis. This is just a horizontal line passing through the center of the lens. Lots of books and examples will show the object drawn on the optical axis, but the optical axis really has nothing to do with the object. It is just defined as a line through the center of the lens. Also on the optical axis, we have two focal points marked. This is the focal point where parallel incident rays converge, as shown in the last video. This focal point is just the same distance on the other side of the lens. So from the center of the lens to here is the focal length. From the center of the lens to here is also the focal length. Once we have the optical axis, we can introduce our principal rays. These are three rays that have simple rules for how they bend when they pass through the lens. So the first ray, all of these rays are drawn from the same point on our object, in this case, the tip. First ray goes parallel to the optical axis and then comes out through the focal point on the far side of the lens. Principal ray number 2 goes directly through the center of the lens and does not bend at all. That is an approximation. There's a small amount of bending that this ray does in reality, but as long as the lens is thin, that bending is minimal and we can ignore it to simplify our diagram. The third principal ray passes through the focal point on the object side, and when it gets to the ray, it comes out parallel to the optical axis. You'll notice each of these rays, or the first and third ray that bend, I show bending at the center of the lens. That's normally what we do. Rather than bending at the front or back wall, we just show the ray bending at the exact center of the lens. The location where these three principal rays intersect marks the tip of our image. It's the tip because these rays leave the tip of our object. If I want to find the base of our image, we simply draw the same three principal rays, this time leaving the bottom of our object. Where those converge will be the bottom of our image. So these are the three principal rays that we can draw for any convex lens. As you know from thinking about mirrors, we really only need two rays to find an image, or at least to find, say, the tip of our image, and two other rays to find the base of our image. Having three principal rays just gives us a third ray to check our diagram, catch if we made a mistake. You will find that in some diagrams, one of the principal rays is impossible to draw, but we should always be able to draw two of the principal rays, and that will be enough to locate points on our image.